Okay, this lesson's going to be on complex fractions, and complex fractions are when you have fractions inside of fractions. So you have little fractions within a big fraction. And there's different ways you can do it. You could get a common denominator and combine the top, and a common denominator and combine the bottom, and then flip and multiply. But I kind of have a little shortcut method that I like to use. And with this shortcut method, I look at the denominators of the little fractions, in this case the x and the y, and I find out what the common denominator is between those. And in this case it would be, you would need both of them, you would need x and y. And I multiply every piece by that. So I have 4 pieces in this one. And when I do that, sometimes you're considering multiplying it on top, but sometimes the bottom is going to cancel, and that would be the goal. So like this x will cancel out this x, and you're left with 1 times y. So I have a y right there, and I have my plus. And then over here I didn't have anything on the bottom of the 3 to cancel with, so I just have 3xy. On the bottom again I didn't have anything underneath the 4, so I have 4xy. And I'm going to say plus, and then over here the y's will cancel because they have the y on the bottom, so then that leaves me with 5 times x, so 5x. And sometimes you can factor these and cancel some more. For example, the top you have a GCF of y, you could take that out, and the bottom you have a GCF of x, you could take that out. But in this case that really doesn't help anything because nothing will cancel after you take those out. If you want to try it, you can see what I'm talking about. But if it doesn't help me, I'm not going to do it. So I move on. I'm going to come to example 2. And so in this case, I'm going to look at these denominators. I have 3x squared, 3y squared, x squared y, and xy squared. Those are what I'm looking at to determine my common denominator from. So think about it as you need to figure out what's going to make everything cancel. So I definitely need a 3 so that 3 will go away, and I definitely need an x squared. Over here I'm going to need a y squared. So this is going to be my common denominator, and it will actually take care of the bottom as well because this x squared will be canceled, and this y will cancel with one of these y's, and vice versa on this one. So I'm going to use this as my common denominator. Three x squared y squared. And I'm going to go through and cancel what cancels. So I have 3 canceling 3, x squared canceling x squared. I'm left with the 1 times the y squared. So 1y squared, and I'm not going to write the 1 because we don't typically do that. And then I have minus, the 3's are going to cancel, the y squareds are going to cancel. That x squared is left, I multiply it by the 25, so I have 25x squared. On the bottom, the 3 doesn't cancel because there's no 3 in the denominator down here, but the x squared does cancel. And this y will cancel with one of these y's. So the way I like to do it is I just mark out the exponent to remind myself I still have a y, but I don't have 2 of them anymore. So I'm going to multiply the 1 times the 3 times the y. So I have 3y. And then over here, I'm going to mark out this x with one of these x's. And again, I'm just going to mark through the exponent to remind myself I still have an x. The x squared cancels the x squared, and I have 5 times 3 times x. So 15x. Now, this one's a little different because up in example 1, I couldn't do anything if I factored, but here I will be able to. So the top is a difference of perfect squares. It's going to factor to y minus 5x and y plus 5x. And in the bottom, I'm going to take out a 3, which is going to leave me with y plus 5x. So I had a GCF there. And I'm able to cancel these y plus 5x's, so it makes the problem easier to look at and easier to deal with. That leaves me with y minus 5x on top and a 3 on the bottom. Okay, moving on to example 3. In example 3, we're going to have to do a little more work first. If you notice, you have this x plus 3 and x minus 3 that are nice, but the 2x plus 6 and the x squared minus 9 can be factored, and you want to factor if you can. That helps be able to determine your common denominator. And so I'm going to rewrite this fraction, but I'm going to factor everything. So I have 5x. This is a difference of perfect squares, so I have x minus 3, x plus 3, and then I have plus. This one didn't change because you can't factor that. And this one down here didn't change. But over here under the 4, I can take a 2 out, and that will leave me with x plus 3. Now, normally you would say, okay, well, my common denominator would be 2 and x plus 3 and x minus 3. But this one actually has a little trick right here with this 4 and 2. Those can be reduced. 2 goes into 4 2 times. Just makes the problem easier. You don't have to have such a big common denominator. So I'm going to erase now that 2 and change that 4 to a 2, just reducing that problem. So I don't have to rewrite the whole thing again. But that had been the 4 over 2, and it reduced to 2, so making us have an easier issue or easier problem here. Okay, common denominator. Looking at the denominators, I have an x minus 3 and an x plus 3 that I have to cancel here. And over here, that would cancel, this would cancel, and this would cancel. So that is my common denominator. X minus 3 and x plus 3, put it everywhere with each piece that's separated by a plus or minus. And then I can go through and cancel. In this first one, they're both going to cancel, and that's going to leave me with 5x. In the second one, the x plus 3's are going to cancel. That's going to leave me with 7x minus 3. In the bottom, the x minus 3's are going to cancel, and I have 3x plus 3. And then the x plus 3's cancel, and I have 2 times x minus 3. And there could be reasons that you would want to keep it like this, but you may also want to distribute and combine like terms, so I'll do that with you. Okay, so I'm going to write down here, I have that 5x. I need to distribute the 7, so I'm going to do 7 times x and 7 times negative 3. So I get 7x and negative 21. And then on the bottom, I'm going to distribute the 3 and get 3x plus 9. And then distribute the negative 2, make sure you take that negative with it. You get negative 2x plus 6. So then I can combine like terms, and 7 and 5 is 12. So 12x minus 21. And then 3x minus 2x is 1x, and 9 and 6 is 15. And that's about as far as that one will go. Alright, so let's scroll on down to number 4. And this is our last example. So you may want to pause and try this one out. This is a good one to try on your own. If not, you can just listen. This is similar to the last problem in that I need to factor before I begin. So this x squared minus 1 is a difference of perfect squares. So I have 1 over x minus 1, x plus 1, because that's how that factors. And then I have x over x plus 1 and x over x minus 1. So now I can decide what my common denominator would be, and remember that it has to cancel out everything. So in this case, that would be x minus 1 and x plus 1. So I'm going to multiply everything by that. And cancel what I can. So I have x minus 1's canceling and x plus 1's. And you're like, everything canceled out, but it didn't. You still have the 1. So I have the 1 over there, plus, and then the x plus 1's cancel. So I have x times x minus 1. And then on the bottom, the x minus 1's cancel, and I have x times x plus 1. And this might be another situation where you want to leave it like this or combine like terms. So I'm going to distribute again and just see what this ends up to be. So I have 1 plus, if I distribute the x in, I get x squared minus x. And then on the bottom, I have x squared minus x when I distribute there. You cannot cancel these x squared minus x's out because of the plus 1. And if you need an explanation on that, I can give you a further one if you'll just raise your hand. But pluses and minuses make it illegal to cancel that. So these just aren't quite the same, okay? And there's nothing that you can do to just make that happen the way you want it to. You might want to see, though, if you rearrange this top part, you have x squared minus x plus 1. And think about, would that factor? So if you think about trinomial or trial and error factoring, there's nothing that multiplies to give you 1 that adds to give you a negative 1. And so that will mean that you can't factor the top. So even though you can take a GCF out of the bottom, this top's not going to factor the way you want it to. So really, it's not worth our time. Let's just erase. And we'll leave it at the previous step. You can put it in order if you want. Just up to you. That concludes this lesson.